Hey folks, this is Tolly and welcome to some more game dev. Today, we're going to take another stab at the balance pass. I think is probably the most important thing. It's kind of blocking a lot of other things that we need to do. We're coming up on the end of week 2 of our vacation of game dev, where we are getting to work on trying to get to a demo before I have to go back to work. We've made some good progress over the past 2 weeks. And I think today we're just going to try and, sure up some of the tuning stuff. So we may get to designing some of the skill trees and the narrative cutscenes. Those are mostly just busy work tasks. But the real thing that we kind of need to solve is the balancing. So I've been happy with our damage numbers for the most part. I think that they're doing pretty close to what I want. We can bring up some of that now and just dive into it today. So if we go back to, say, this one as an example, and honestly, we can just hide a lot of this information. This is me playing around with stuff off camera, but essentially what we do is we look at the player's attack and their enemy's defense, or this could be, honestly, the enemy's attack and our defense. So the naming's a little weird, but really these are just the attack value in blue and the defense value in purple, and then we have an ability power. So each ability has its own power value, which means that certain abilities can do more damage than others, regardless of what the stats are. And the way that I'm kind of doing my formula is based on Final Fantasy VIII originally. So Final Fantasy VIII had a bit of an attack to a certain power divided by a stat plus the attack, and then times that by essentially a ratio of the defense with a slightly larger number, and then timesing all that by the power of the ability. And that felt pretty close to what I was looking for, and it's been working okay. So if we look here, the thing I like about this, we've modified it pretty heavily. We've taken that defense ratio and we're doing a bunch of different stuff to it in order to come up with a defense factor, essentially making it so that the values can be a bit more weird. I might want to reduce this at some point as well, but overall the stats are doing what I want. So if I increase the defense by let's say 255 and then attack 255 with 100 power, that's going to get me up to this really high number, and I want to kind of cap us out at 9,999 so that we have a cap of essentially 4 digits. That feels pretty good to me, and with our kind of low resolution pixel, we're probably not going to be able to get much more kind of font information up and running. So this is a little bit off, but I kind of want to have some room for us to go over. I'm pretty sure I don't have anything wrong in any of this tuning. No, looks okay. I will be honest, it felt like I was holding at a much lower number. Did I change? I did. Did this make a difference? It did. Okay. I was playing around with some values over here to try and change how much defense had, and I modified this plus 0.1 to be 0.2, so that's why that was a little bit different. But essentially, if we have max stats on attack and defense and max power, we're going to be getting close to our damage cap. And then obviously if you're fighting something that has a little bit lower defense, you're going to see that your damage will go a bit above that. So this is feeling pretty close to me. And then when we're on the low end and we're doing let's say even 10 with a 10 power ability to start, that's about 16 damage. And that feels pretty good to me too. And if we were to do something like a kind of low mid game experience with something like this, we're doing about 700. Once we get our stats up to about 50, we're fighting enemies that are a little later in the game with 50 defense, and we have a power of 30. This is kind of giving us a number of 700. Maybe that's a little high. Maybe we might want to tweak that. But right now I'm feeling like this seems like a pretty good trajectory. It means that early on we're doing about 15 when we're low early game. When we're mid game ish, I guess maybe you consider mid game more like 225 with 50 power. We're doing 3,000 damage, and then as we go into the kind of end game experience, if you max all of the possible stats, you're going to start doing 9,999 in the late game. And that range is what I'm looking for. I want it to feel like we're doing a little bit of damage, but then we quickly scale up into the thousands, the hundreds and thousands, and then when we get to the late game, we're kind of capping out. But there's a problem. As much as I like this range, and I like the way these numbers are working and the way this formula is working to create those numbers, the primary issue I'm running into right now is that if we say have a even early numbers here, go back down to 16, 15, 16 kind of numbers, and if we want to give the player +1 stat in the skill trees, so they get 1 defense stat, it modified the damage that's incoming to us by like 0.3. And that feels bad. Like, I don't want to have to spend points on a thing that I may not even see the difference on when we add that 10% modifier. So I definitely want to make it so that defense point of 1 or even defense point of 2 makes a difference on the amount of damage that I'm receiving from enemies. So I've been looking at reworking things a little bit, playing around with some numbers, and honestly, seeing as I have a backup on the other file, we can't just delete that one. Okay, what if we replace this with this? That also breaks things. What if we drag this over top of? Also breaks some stuff. Okay, well, sad. Actually, you know what I can probably do? The main thing I've done here is I've removed on this page a lot of my formulas that were like hidden information. Namely, this thing was doing defense applied formula, which sounds great, but really all it was doing internally was timesing these two numbers together. So we're just going to fix this so that we can reduce the amount of information on the screen. And then same thing here. We want this to be, instead of final damage being equal to that, we actually want it to be the first number times the next group of numbers, with R1 being the divider. Is that what we want? No, because that changed the number pretty heavily. Oh, it's different again because this here. Okay, cool. So this value here is going to be timesed by E3, which is the ability to power, divided by R1, which is the power divisor that just like brings the values back into a range I like. Okay, so now we should be able to delete all of this. We're even going to just like get rid of all these green ones. Okay, so I'm pretty happy with the way these numbers are working out, but we want to give defense more value. And one thing I found here, and I don't know if this is the best solution, but in playing with things, I've discovered this. I'm a real brute forcer. I don't know if we've said that enough on stream, but when I need to solve a problem, I do not go look up the mathematical formula. I do not follow a tutorial. I will spend 4 to 10 to weeks to just like trying stuff until I figure it out on my own. And then I try and talk to someone to be like, this is what I did. And then a friend might just be like, you've done it dumb. But I like to solve things to understand the kind of like basic interactions on my own. So what I've been kind of trial and erroring around with is like playing around with, what if we had some sort of ratio between attack and defense? And I was doing a bunch of nonsense, doing this as an exponent, and I was trying to multiply these values and do all these things. But what I found was really all I need is the attack value divided by the defense value, and that gives me a value of 1 here. And if I increase the defense, I get a lower number. And as we keep increasing that, we keep going closer to 0. But as we get up to like say 150, we get progressively closer, but it doesn't seem like we ever get to 0 because we're just dividing this number by an excessively larger amount, but it's never going to get to 0. So that's kind of neat. And then I was like, okay, well, what if we go the other way? What if we start increasing this? Well, the number gets larger, And this seems pretty straightforward, but for whatever reason, I was trying to do a bunch of complicated formulas when I think in reality, this might give us what we're looking for. Essentially, the difference between the numbers should give us some sort of value that if we multiply the final damage by that amount, we should essentially be able to kind of create a defense to attack ratio. And or maybe you'd say that the other way around, but regardless, if we do this and then we add an extra defense here, this number gets smaller and we see our damage number drop by a little bit. Now, I was seeing a bigger drop here before. Right before camera rolled, I was playing with this and I was seeing more of an impact. Is that because I had this still at this larger number? No. Probably shouldn't have deleted the work I did while explaining this. Oh, where is this number? Oh, this number is not the same formula. Okay. Okay, that's what we were seeing the difference on. So if we look here on this spot, it is changing as I expected, but I hadn't updated this one, which is where my eye was drawn to. So yeah, so if we increase the defense by 1, we get like a 2-point drop, basically. And if we increase the defense by 2, we get approximately a 3-point drop. So the more you increase the defense, the less of a value it's going to be, but you will see more of an impact as the defense keeps going up. So if we're fighting an enemy that's pretty fixed in its attack value as we go through the early zones of the game that's doing 10 attack, then going from your starting defense of 10 and even getting 1 point should see a drop in damage that is somewhat significant. At the very least, you'll notice, even if it's just a point or two of damage, that something has changed. Opposed to before, without this addition of this ratio, we were essentially not noticing the defense at all. It only really mattered as we got higher. So obviously if the defense stayed low, we get much larger numbers. So if you weren't continuing to upgrade your defense, you'd notice that on further enemies, but I'd like to have it so that you still notice the defense at least a little bit when fighting enemies that in the zone you're at. So I think this might be all we need to do to manipulate the formula such that the more difference there is in the defense to attack stat, the more impact it has. And I just want to double check. So if we play with some of these numbers, I'm still experimenting a little bit. If we say we have a mid-game experience here around, say, 3,000 or so, and I get an extra point of defense, now it's dropping by like 60 points of damage. And if I'm below and at like 149, then yeah, it's about 60 points either way. Is 60 points making a huge difference at this scale? That I'm not so sure on. And maybe after we release the demo and we get into more of the mid and late game experiences, we might find that this formula needs further tweaking. Like maybe this needs to scale differently, or maybe this defense factor is kind of overcomplicated and a bit ridiculous, which is some of the things you get when you're brute forcing. But I know that with these values, I'm getting that, again, that kind of low, middle, late game numbers I'm looking for. The only real problem I've been running into is really just the difference between 10 defense and 11 defense in the early game. And this definitely feels like it is giving me that kind of range that a player would hopefully notice as they increase their stat. If we wanted to increase this value so that it has more of an impact, I would guess, just out of curiosity, what would we do there? So if we start at 10 and going up to 11 gives us a 0.9, and this gives us 0.8, it has like diminishing returns. Then I assume if we started at like 8, we're doing 23, and then 1 point here. No, it's still about a 2 or 3 point change. So I guess if we wanted to make it to a larger kind of impact, we could just increase it. And then by increasing it, it'll double the amount of impact it has. But this obviously increases our number of our damage, so we could change the power divisor to bring things back down. Oh, no, we'd need to bring it up. So that would bring it back down on the power side. And I guess this means power would have less of an impact. Yeah, so that would change the amount of impact power has. So it would, if we increase this ratio, that means our numbers are going to be larger. So we need to change the power divisor in order to bring the numbers back down. But then if we brought up the stats back to where we want them to be for the end game, it looks like we'd still be relatively fine. Yeah, I also don't think we need this. I think 0.1 is fine. In fact, if we just get this completely out of here and just do 0, how much of an impact does that have? What if we just don't do this part? Does that do much? I guess it's slightly growing the number. It's like reducing the impact that defense has. In fact, it's actually making it so the defense factor is above 1. I think this was more of a flat rate to make it so that no matter what the ratio was, we were still increasing it. And I think this is kind of an odd way of doing it. Let's see if we can remove that from the formula and still create stuff that we're looking for. Oh, interesting. If we remove that completely, our endgame numbers go completely out of range. Huh. See, this is where when you brute force stuff, you never really know what you're doing, though. So, yeah, I need that. I don't fully know why, but it keeps the numbers within this range I want. So although it's a bit complicated and a bit odd, it's doing what I want. And I feel like I probably spent like a fairly large amount of time brute forcing this like a couple years ago. So maybe we shouldn't mess with that too much. Because everything else is working. But if we get rid of this completely, just this part, and we leave the times defense ratio at the end, really that's just like another power here. Kind of. It's like this to the power of 2. But yeah, the 0.1 versus no 0.1 drastically reduces the end game damage. Yeah, interestingly, if we have this at 0.1, I notice less of an increase, or a less of a change here now. Because before, when this was kind of defaulted to 0.2, from 18 to 16 would be bigger change. Huh. Let's try graphing this. Let's take all of these formulas and let's convert it into one cell. I'm going to duplicate this tab again, just because we're going to mess with stuff. Graphing. And it looks like we have some extra columns on the front here. Does this do anything? This magic number? It does not. Okay. And does this do anything? Nope, just a bunch of hidden information. So if instead of doing... Let's unmerge these. Let's take this value here. Yeah, this is going to be a very long formula, but we're going to do... This is equal to... That's the starting part, which is the attack. Then that attack needs to be used down here as part of this formula. It might be easiest if we just do all of this in columns. So first we generate the attack. Then we're going to generate the defense ratio. Which is going to be this value. Okay. I suppose we can add a row above this with some explanations. So this is base attack. This is defense ratio. Let's reduce the size of these. They don't need to be nearly as long. Then we convert that into the defense factor, which is this crazy formula here. But instead of it being Q13, it's now going to be this C2, C2, T5. I suppose we can keep pointing at some of these other values off to one side. This becomes C2, and that should be okay. This I2, I think is going to become A2, or, yeah. Because this is where we were going to put our defense stat. We're going to leave the attack value here, but we're going to make a long list of all of the defenses so that we can kind of see how the values change. The trick here is that we're going to want to see how it changes in relation to the attack stat going up. But we can modify that piece by piece. I don't really want to create like a 3D axis. Okay, so then from here, this is the defense factor. And then next we need the defense applied, which is the based attack value times the defense factor. And then once we have that, insert to the right, then we need final damage. And that's going to need to be this formula, which is going to be R15, which is the defense applied. Yeah, we can kind of just do it this way. Defense applied times the power value, which is going to need to be this one. And then we're going to need to put some dollar signs in here. We'll have to go through all of these and make sure we do this, because we're going to drag down and we're going to want some of these values not to change and other values to change. Divided by 8 times... I guess for this we can just do this divided by this, and we'll just build it in here. Except this is going to be A2. Okay, this value needs to have dollar signs so that it remains fixed. That's A2, that's going to be modifying. C2, that's going to be modifying. U4 and 5 should be fine. This one needs to modify, and D2 needs to modify, so that's okay. First time chatter on Twitch, BB, hi, what you doing? We are working on some damage formulas for the JRPG tactical game that we're building. So trying to see what impact adding a like defense to attack ratio has on our numbers, and seeing that like if we add just a simple defense or attack divided by defense times 2, it kind of has a like the effect that we're looking for, where changing the defense up is giving us like a 2 or 3 point change in our damage. But I want to graph that and see how that looks. This is H2. This needs dollar signs. Also, in explaining that, I just realized that this final part here needs to be times by 2 because that's what we were playing with for like a scaling factor on it. So E2 doesn't need to change. H4, H2, these all seem okay. So yeah, if we drag down now, in theory, we should see those damage numbers change. So as defense increases, we can hide all of this now, assuming I've done it correctly. Values drop. Okay, so something's not quite set up right here, because defense 10 with an attack of 10 should be giving us the same output of this. So we are... Oh, this 8 needs to actually be this value, and that value also needs to not move, so we'll put some dollar signs in. Okay. Cool. So as our defense stat increases, with the attack being 10, we will see approximately a 1 to 2 point defense, or a 1 to 2 point damage reduction, until eventually we get up to the point where we're starting to see like kind of diminishing returns. That seems pretty good. Let's reduce the decimal points here to something a little bit more readable. I suppose if we wanted to have a better idea of how this works, we could insert a column to the right, and we could do this value minus this value. Or maybe we do that one step down, actually. This value minus this value. And this will tell us the net change. Net change from defense stat. I'm actually seeing that kind of laid out. I'm pretty happy with those diminishing returns. And so if we increase this attack value by here to 11, then it's interesting because as this one changes, we kind of have to change our mindset. So when we're at 10 attack, then this is our current like equal damage. When 10 is 10 attack and 10 defense, you would do this, and every extra point of defense is adding this amount of change. But now this is our equal point, so 22 damage, and so now our net change is 2.1. So we kind of need to kind of mentally keep track of where the cursor is here as we modify the attack value. So when we're here, it was a 1.9 reduction for 1 point extra. Here it's a 2.1 reduction. And I assume as we go up that changes. It does. So from 12 to 13, it's a 2.1. So defense becomes more valuable the bigger the numbers get. And again, that makes sense because as we start getting larger numbers, the damage we're doing is starting to get much larger as well. So we see a larger net change from the defense stat because the numbers are growing over time. Okay, so again, that makes sense. So here, 15, we'd go from doing 38 to 29. Let's drag this down a little bit, and then I just want to have range to go up a bit so that we can start at a slightly lower defense values. That did not work. Okay, what if we do this the other way? What if we start at like 5 defense and then we select both of these and then drag down? Okay, that does work. Okay, so if we go down to like 5 attack, 5 defense, that works a little better. Let's also rearrange this a little bit so it's a little easier to read. I'm going to insert 2 columns to the left so that we can move these values over. Hopefully this should work. Okay. It does. Defense stat. And then we can hide all of this information. I think seems reasonable. These ones should also get moved over. They're used as part of the formula, so if we're tuning those, they should be used. How do I easily select all columns to the right? It has been too long since I've messed around in spreadsheets. Let's just do it manually. Okay. So now, assuming that we have a attack value of 10 here, our damage will be around 18.5. And if we go back up to our 255 attack with 100 power, and we were to drag this all the way down to 255, which is our max defense stat. Oh, well. Helps if we multi-select so that the sheet knows what we're doing. Let's make sure this works. Seems like it is. Interesting. So we get some pretty big final damage numbers, obviously, if our attack value is crazy high and the defense stat we're hitting is pretty low. I still like... So the problem is at 0.1, we're kind of going to cap out at where I'd like the damage to be ending a little bit better. But then when we go back down to the low numbers, the net change from, say, here to here is much less noticeable. I think we're really close. I think this formula is almost meeting all of our requirements so that defense has value early on, and we still have a range of approximately like between like 15 or so and 20 low damage at low stats, mid stats. What were we saying? Mid stacks is like 125, I guess, is somewhere in the middle. So when both our attack and defense is 125, somewhere around 600 it looks like. And then when we're at, oh right, we need to modify the power up because we would also be expecting we're doing like mid-level power, so 50. Yeah, so about 3,000, which is what we were saying. And then when we get like high end game stats, that's when we want to be doing 100 power abilities with 255 attack versus approximately 255 defense, and we want to be capping at 9,999. So like that's the spread we have, and by adding this defense factor, let's make this a value that we can actually tweak. Attack defense factor. So instead of that just being hard coded to 2, we'll need to modify that with some $signs so it doesn't change as we drag. And then let's bring the values back down again to something I know. Okay, that's working correctly. Let's auto-complete that all the way down here. Okay. So then the question is, can we say increase this to a factor of 3 so that there's a larger delta in change here? But then we'd have to increase this by 24 to bring it back down. And then 10 versus 10 is still... That makes sense. So we can't really modify these because if we modify this value versus modifying this value at the end of the equation, or sorry, B16 being the power divider versus the attack multiplier, this final step is all attack and divisions. So changing this one up or this one down doesn't really have much of an impact, which means I guess if we did this versus this, that shouldn't make a difference. But it kind of does. Oh wait, because that should be 8. Yeah, okay. So we don't even necessarily need... Interesting. Yeah, so this attack defense factor isn't even doing anything. We could just modify power divider if we wanted to kind of change the scale of these numbers. And if we modify this like odd defense factor value that we have, that raises the numbers by a little bit in the early game. So keeping an eye here on this tile or on this cell, 10 defense versus 10 attack is like close to 17. But if we increase this value, it goes up to 18.5. So it's like a 1.5 increase in damage. But the problem is we see that at the end game too, where now our max attack values are way over where we'd want them to be. I mean, obviously we're going to just put a cap on damage. But I'd still like it to scale up nicely. So then I guess the last question is there a way to increase this value in the early game so that there's more of a spread in how much impact defense has. We want to have more of an impact on the defense. So the delta is larger, but we don't want to change the kind of amount of damage that we're doing. So we want to leave the, if all stats are the same, 10 versus 10, 10 attack versus 10 defense, we want to leave the numbers identical. But we want to find a way to make it so that if there's more of a difference between them, more of a delta between those stats, it has more of an impact on the delta of damage we see. But we don't want that to impact... My brain's going back to the exponent stuff. Like a way of modifying those values. We're missing something. Okay. Can I cancel out? Thank you. So if we add exponent here, that value massively changed. So we want to be able to modify this value such that like 16.9 remains the same, but the values around it have more of a spread between it. And this is our defense stat. No, that's our attack stat. This is our defense stat. So if there's more of a difference between these, modify the formula. What if we do... This is crazy. But what if we do exponent of each one? What impact does that have? Does that widen the gap? So that means that this remains the same. But if we go up and we go down, that does increase it. So the number remains the same. And if we go back to 255 with 100 power, I mean, the numbers at the beginning get insane, but we stay the same here. This is still the same value we were expecting. And just to be on the safe side, 125 versus 50, if we look at the 125 defense stat, we're still seeing about 3,000. Okay, so if we raise the value of the attack and defense stat to an exponent before dividing them, that creates more of a range. But this is almost too much of a difference. I wouldn't want to see like a 10-point difference. All an exponent is just that seems to be implying that all an exponent is just a value raised to the power. So if we do 10 to the power of 2.6 approximately. Did I get the ordering wrong? 0.718. 718. Yeah, off by a couple of decimal points, but otherwise it's the same. Okay, so then to reduce the spread, we could raise each of these values to a power, and as long as the value we're changing them to is the same, they should divide out to still be 1, but it'll increase the spread. Okay, and then the first number is what we want to be raising. So if we just did 2, for example, this is getting too hard to read, I think. So what we'll do, let's expand these columns. Let's insert one to the right, and this will be the attack / defense factor. And that value will be equal to the power of 2 to this attack divided by the power of the defense value 2 to the power of the defense value. Except this needs to be set up like this. Such that this is 1. Okay. And then each of these, we can kind of get rid of the multiplier part too, is just this value now. This actually makes it much easier to see what's happening. So then if we lower this to 1.5 or something like that, and then drag that down through, it's still too large of a spread. That's too small. So this is some factor that changes the amount of impact this has with diminishing returns still. Oh, with occasionally negative values. Okay. Let's make this something we can edit elsewhere in the sheet. So let's repurpose this. And then more $signs all the way to the bottom. Oh, that seems weird. Why would that all be 1? Oh, because we've made this 1? Yeah, that makes sense. Okay. So more of a spread that way. Okay. And then we just need to make sure all of these are set up correctly to be using the right values as well. Now, the major difference between these two factors seems to be that when we do it with this power spread, we can reach like full 0 numbers because the difference gets so large over time. So if we were at like say 50 attack and say 50 power versus an enemy who had 50 defense, we'd be doing about 1,000 damage. but every point of defense would pretty drastically reduce the damage. I think this is what I'm trying to get at. Okay, I think we've got it. It's just now a matter of like figuring out what we want these numbers to be. So let's hide these again, because I don't really need to see most of them. I might keep the defense factor one open, because it's kind of curious seeing how it gets modified. Reduce the amount of digits. So if we make this factor like 1.01, that gets us much closer to... Oh, not even. I want to see what the original was. Insert to the right. If we just do this value here, divided by the defense stat. Oh, it didn't autocomplete that time. I would like you to autocomplete, please. No. Okay, fine. Oh, B2. B1. Okay, that's the mistake I was making. Let's switch it up to here. I think we've come out the other side and things are getting interesting. Can we just make these normal plain text? Nope, that's not what we want. I think I want to cross compare. I filled something out incorrectly there. C2, which is the defense stat. Oh, that's not right. We want to multiply this by defense applied. Okay, there we go. Cool. That's right. And then I also want this net change as well. Insert to the right. This should just work. Okay. So then we can hide this. This is the way we do it with power. We will tint these yellow. And this is the way we're doing it without adding power. Tint this green. So essentially, at the point where we are at 1, the factor of 1, between the attack stat and the defense stat, here we would see a 0.4 damage difference. But here we see a 1.8 damage difference. If we increase this to like 1.05, that increases a little bit, so that there's a 1 damage increase, or 1 damage difference. Just out of curiosity, if we go another 5% or another 0.05, then we get back to that 1.8 difference. But it maintains that small incremental difference longer, so it has less diminishing returns. Interesting. Oh, and as we increase this value, we get a larger increase in damage as the difference changes, but then has more quickly diminishing returns, it feels like. So if we go up to like 1.25, then from 10 we have a 3.6 damage difference, and then 2.8, and then it falls off again. 1.5? 5, 4, 2. Huh. Yeah, I think this is doing what we want. It allows us to keep our range. It doesn't affect how the damage scales, but just by modifying this attack defense factor, which is how much we're applying, what power we're starting with, and then raising the attack or defense stat by that amount, it creates more of a divide between the final damage numbers. And then just by multiplying that to the end of our final damage, it just like helps differentiate the defense stat and make it more visible. The question is just going to be how much we want this value to be. I think it's somewhere around 1.3. So this is basically... I guess that makes sense. Basically, it's giving us a 30%... Does that hold 1.5? That's 50% up. That's 33% down. This is interesting because by applying this, it also means if you fall behind on your defense stat, you're going to notice the damage way more. So if you have an enemy that's hitting you for, say, 10 attack, well, let's even go a bit higher. Let's go, say, 15 attack. Oh, wow, that's a pretty amazing spread, actually. If they have 15 attack and you have 10 defense, they're going to do 289 to you. Meanwhile, if you're at the appropriate amount, they're going to do 35. So this is going way too intense, way too fast. If we bring this back, actually before we modify that, if we look at this one over here, this should be the same information. If we change this back to 10, yeah, these are changing. So if we look at the green columns, here we're at 35, and then at 10, if you're still at 10 defense, they're doing 57. That doesn't seem nearly as brutal. It's still a lot different damage, but it's not like 100 different. So 1.5 is probably too high. Is that the same at 1.3? 10 versus 10 here. We're seeing 141 versus 57. So it just climbs way too quickly. The difference is being modified too heavily. That makes sense. We're doing power stuff. It's getting exponential. We go small numbers on this. Oh, it just basically flips things. Okay. So 1.05. Then 10 versus 10 remains similar. $35 on both. But if we go back down to 10 defense, it's less of an impact. Yeah. So 1.1, which is about a 10% stacking value, seems similar to the spread we get for just doing an attack divided by defense. But this one still grows more quickly over time. It has similar values to start with. Well, we see that this one's 1.1. If we just make it match. No, there's still a divergence over time between them. Okay. So it's really just a question of what do I want this value to be? I'm going to think on that. In the meantime, let's implement. So the only real change we've made here is everything else remains the same about our damage formulas. We're still doing the same base attack formula. We're still doing the same defense ratio, this weird defense factor thing that I like that seems to do what I want in terms of the range of values. Defense applied is still the same. And then the final damage, the only difference here, instead of it just being defense applied times the power of the ability divided by the power divider to bring it back into the number range we like, it's just adding this factor. So this should be relatively easy to add to our damage formula. Oh, my eyes. Going from the pure white of the spreadsheets to the dark of the Visual Studios. I'm sorry. I'm so sorry to all those watching. Okay. So this is damage applied. So right here, we want to times this by float defense attack defense ratio. Attack to defense ratio, which for now we'll do the power version. So far, I haven't seen much of a performance hit from doing some basic math. I'm sure it will be fine. So this needs to be a value. It looks like most of our other values are baked in here. Yeah. Don't love that, but it is what it is. I think for this one, I'll at least put a attack to defense factor, and we'll make that 1.1. To the power of the attack value, which is just attack here. And we're going to divide that by math f dot power of attack to defense factor of the defense value, which is just this value. Okay. And then we're going to times the final damage formula by that attack to defense value, which you don't like because we're trying to convert to an int. Right, I see. This just needs to go inside the brackets here. And I'm going to just add this here for readability, but it doesn't really matter. Okay. Okay, cool. Perfect. I think that's worth testing at least. I don't know why we were debugging, but we can stop now. Let's go into Unity. Over an hour to actually get to the editor. Listen, some people had asked, how do you balance games? This is part of it. And I'm not even showing the whole creation of the formula. I mean, again, some of it's based off of Final Fantasy VIII as like a starting point at the very least, but like... Oh. But yeah, I'm only showing like a fine tuning right now. What broke? That's interesting. I'm gonna guess that's to do with the goddess. I was making some tweaks off camera and fixing some things, and I broke some other things. So in yesterday's stream, we had made it so the UI system, or the AI system, knew when a unit was revealed via an actual like reveal value inside of the unit. And I thought I didn't like that. I didn't like the way that was feeling. It felt like a weird thing to have inside of the unit class. I've now since made a visibility class in the same spot as a lot of the other unit related stuff. And now visibility is handling the reveal value, allowing the AI system to access this, and has the actual reveal function inside of it. And where we were originally calling reveal on the unit, we're now just calling on the unit's visibility component. Again, it's not that different, but it's just an improvement to make it so that some more of that logic is encapsulated and the unit class doesn't become massive. But in making that small change, I forgot about the goddess prefab, which is an NPC for the initial cutscene, and it will also need to have visibility information now. It will not have an alert ability that it'll play, which is the whole point of that, but it still needs to have the components hooked up in order for the engine not to break. Okay, so we go through the initial tutorial here. For anyone watching this video randomly and having not seen the game before, this is what we're building. We're building infinite retries to defeat the Demon Lord, which is based off of the concept of like an isekai. The goddess is explaining to us that we're going to save the world, essentially, and then we get sent down on our very first run. And now that we're in the forest, we get a little dialogue, some more UI turns on. The character mentions being isekai'd and having stats like a video game. The snake is eating its own tail, is what I've said a number of times. Right, we had auto reveal turned on for this one. We'll pick up slash. Not clearing darkness because we revealed the whole zone. A lot of this is also placeholder art. We're just trying to figure out what we want the kind of shape of things to feel like. Trixie's still working on some of that, and then we'll kind of revamp it to be less flat colored and actually look like something a little bit more in line with what we're trying to achieve. Okay, so this is our first enemy. I kind of want to run past this enemy if we can, because I'd like to create a save where we can actually fight the enemy more easily. This should make an autosave for us that we should be able to get to from the boot screen. How close is the enemy in this room? That's mildly far away. I think I want to go all the way to the next room, which is going to have even more enemies, and that'll probably a better save file to keep for testing combat and balancing. Okay, so from here, oh, what did we make the save button again? Debug tools. Save screen, the O key. Let's make a... Probably can save over these. They're pretty old now. Yes. All right, TO5, and then I'd like to just test... Well, let's see what those damage numbers were. I feel like the damage was a bit low. Yeah, we're taking 2 damage. That seems off. But maybe that's accurate now with the damage being more heavily scaled by defense. We'll have to see what the stats are. I kind of want to just check and make sure that save file is working. So let's go back to... Oh, right. We're still on boot screen. Let's continue from that save file and make sure that we've skipped all the tutorial, because we're probably going to test this a number of times. So we'll load here. Yes, please. And we should load up with slash and all the UI on. Yeah, we hadn't really tested any of the tutorial stuff. Yeah, that all looks good. Okay, so we're taking 2 damage from this enemy. Let's validate that with our spreadsheet and make sure that that is what we would be expecting with whatever the numbers happen to be. So we'll look for the enemy. The enemy starts with, I think, some hard-coded stats for the time being. We'll need to eventually modify that to be based off of some design data, but they have 5 attack, 5 magic attack, and then 10 defense and 10 magic defense. I believe all of our abilities are framed as physical for the time being. So the enemy has 5 attack and 5 defense. Let's go back to our spreadsheet and let's document that. So we know currently anyways, we may change it based off of how these numbers map out. The attack of the enemy is 5 and the defense of the enemy is 10. And that is for the enemy. For the player, I believe we are starting with some pretty reasonable stats. Let's take a look at the player state. We are also hard coding the initial stats, but that doesn't happen here anymore, right? That happens as part of the unit state. Sweet. And this is 7 and 11 to start with. So the enemy is 5 and 10, and we are 7 and 11. And that's because we wanted defense to be a bit higher because it wasn't feeling impactful. So if the enemy has 5 attack and the player has 11 defense, we would expect the final damage to be about 2. And then depending on a 10% change, I could see that rounding up. So that is looking pretty close to accurate. What factor did I end up putting into the damage formula? A 1.1. Yeah, okay. So that means if we were to change the enemy's attack value to be 10, we would expect that then with 10 versus 11, we'd expect them to be doing about 15 damage. So let's give that a try and just see. AI. And then we will change this to be 10 and 10. And we'll reload the save and see what happens. But I would expect we now take 15 damage. And it's a 5-point swing. 5-point stat swing on the attack changes the enemy's attack from 2 to 15. I think that makes sense to me. Yeah, there we go. Okay. It's going to be important for me to get these numbers right. Like the starting values of the enemies is going to be a big deal. Let's use slash a few times. Oh, we copied heavy attack when we made slash last night. Yes, yesterday. Wow, time is crazy. Yes, yesterday we made slash. And because we copied dungeon props abilities slash, because we copied the heavy attack, that means its cost is a little too high. Here, 1. We'll do that for shoot and bash. We'll make them all the same. We'll make it so that all 3 starting abilities are identical for now, just so it doesn't matter which one we pick. And then I just want to try increasing our stats a little bit and see what happens. So we're going to change slash. The numbers are pretty consistent, feeling pretty good about that. We got to figure out what's going on with the enemy's death animations at some point, but I'm less concerned about that. And then we're going to get hit and probably die here. Yep. We should have gained some stats on that ability. We did 2. So we can unlock strength. And we can increase our health by 5. Oh, interesting. This is not updating as we modify the attack value. That implies that maybe the stats aren't actually being modified correctly. I've been focusing on this whole system from a defense standpoint, but I guess if the enemy has 10 defense to start and the player is dealing 7... Is that right? Yeah, we should have started with 7 attack. Interesting. Well, I don't quite remember how much damage we were doing. But so this implies, though, that we should have been doing about 6. And if we go up to 8, with this new system, we'd be doing 9 damage. A 3-point swing. Interesting. Okay, so we've made defense more important by making it have more of a spread, but I guess I hadn't really thought about it this way, but that means that attack is also going to feel more impactful, because the closer you get to the enemy's actual defense stat, or above it, the more of a spread you're going to get each time. And right now it looks like, at least in the early game, it's saying they have 10... Yeah, like 3 or 4 points of difference. Very cool. Okay. I'm liking that aspect of this formula. So not only does it make defense feel more important, it also makes attack feel more important as well, because if you're below, or even if you're just raising it, having a high attack value in relation to the enemy's defense just is going to increase the spread. Okay, that seems great. If we go out of this screen and back in again, our attack stat is still 7. I don't know if there's an easy way. Oh, you know what? That's probably because it's checking the unit, and we're not updating the unit's stats until we enter into the world. So if we look at the player here, this one, they should have a stats component on them. Can we view that from the editor? Not by default. And these values won't be correct because this is the data-driven stats, so it's not even here. It's stored inside of the save file. Yeah, so we don't actually have a way of seeing the stats. I suppose I could end the run and then go take a look again. Still showing 7. Curious. Let's take a look at the stat ability node. Node? Stats node. Infinite retries variation. It should be modifying the state by the amount. Okay, well, let's validate that. Maybe the UI just isn't hooked up to update correctly, but I would think at the very least leaving the Goddess Realm and coming back should have changed things enough that we should be able to see the stats being modified. Curious where this is getting refreshed. I cannot edit. Alright, stop debugging, break, or delete all breakpoints. Then try debugging again, see if Unity cooperates this time. Unity is thinking at least. Okay, we are doing like 14, 15. That's what I was afraid of. So these numbers don't make sense for how much damage we're doing. Because we should have 7 attack versus their 10. Why did we not hit that breakpoint? Interesting. Oh, wrong one. Why are these not valid? That's valid. See if we can at least hit that. We can. Oh, interesting. Did we never call unlock? This is a stat node. We don't treat it like a stat node? That shouldn't matter. This is a virtual value. This is overriding it. This is all within infinite retries, so the namespaces should be fine. Why can we not get here? Super interesting. I mean, we're not seeing the stat change, so this would imply that maybe it isn't able to find this. Okay. See if we can at least get a debug print. I wonder if we can add something in here that like allows us to debug purchase things. No, I'm just going to add a toggle. Well, this would be easier. I don't have to go find the script every time to modify it with, like, ticking it in the editor. What are the options here? This is while the holds down the key. Okay. Keycode.shift. Left shift. That's going to break things. Control. Left control. That's still not going to make it work because we still need to have enough stat points in order for it to function. And I don't feel like adding this into a bunch of spots. Maybe it's not that bad for now. This seems awful, but I just want to test things. We'll have to tear that out. I don't even think I'll check that in. I might just leave that local for now. I guess to be fair, this is the first time we're actually testing increasing our stats. We got the whole skill screen working a few weeks ago, but we never actually like validated that like I could see that I was purchasing stuff. I was able to click in the UI and see the buttons were changing state to represent that they had been purchased. But I suppose we had never actually validated that the stats were changing. Alright, left control. We're hitting is unlocked. Did we hit the print? We did not hit the print. Okay. Okay. Yep. So I would guess when we save and load, when it loads up the game data, it loads up everything as nodes and doesn't actually deserialize them properly into their individual base nodes. Increase. I see, I don't need the command here. This is only checking to make sure we're not trying to repurchase the same one twice. So this is a pretty big bug. And the reason that it shows the correct description is that we set that value and then that gets saved out and loaded back up, but that's something that's stored inside of the node. So just because it's loading it probably as just a base node, it doesn't use either of these functions. Okay. Trixie with the hydration redeem completed. Okay, so we've balanced. I'm pretty happy with the damage formula that we've got now. I think this is going to feel really good. Attack is going to feel super great to upgrade. Upgrading defense stats is going to seem really good too. It's going to feel important and meaningful if you don't do it. The real problem here is just the fact that the stat nodes aren't actually increasing our stats. Because that's going to hamper us from being able to actually kind of play the game. How do I fix this? Where do these get used again? It's inside of the ability specs, right? Yeah, we have a list of these nodes. And then this gets used inside of our backend unit state manager. So this has the unlocked ability states that we store inside of here. And then when this is all part of the unit state. And we serialize that out to object. And then we from object this is us converting this JSON JToken back into a unit state, and this is us converting it into some save data. But when we convert it back out into this object, and it populates the ability specs, and inside of the ability specs it populates the nodes, because it doesn't have any information to know what type of node it was, even though the information is in there, it just creates them as just nodes. Okay. We need to rework how we save ability specs. Oh my god. Okay, this is gonna take a while. What do we need to do? We've got 20 minutes left in this stream until I'm going to take a break for dinner for 2 hours, and then we'll be back again at 7. Let's just figure out what we need to do. So, inside of ability spec, we have a list of nodes. That list of nodes is the information of all of the skills or the skill tree nodes that we're going to be unlocking. All the information about them. Those get generated somehow though, right? Like we make these for the first time via some sort of factory. Here, when we construct the ability spec, we go through each of the design datas, and then we create a node. I don't think we should be saving this list of ability specs. I think this should be non-serializable. And I think we should have a separate list of information that we want to save. Let's take a look at let's take a look at the dungeon state manager. Inside of enemies, states, dungeon snapshot. Okay, so when we go to save the position of the enemies, we don't just save out the whole unit. We don't just go, hey unit, here you go, pass the whole thing out. Instead, we take a snapshot of the current existing information. Think. Like, where do we modify these states for an enemy? Because what's in here? Let's take a look at what's inside of an enemy state. It's really just is defeated, which gets set to true as part of a battle results. So, like, let's go take a look at the board. The enemies may be a bad example because we're not even using this, really. We don't really keep track of that information super well. because all of that is Era of Ember stuff, and we haven't really updated enemy death tracking for infinite retries yet. So let's go back to the dungeon state, and let's take a look at the dungeon room manager. So when we go to save the state of the dungeon, we do a dungeon snapshot. Where we create a room state based off of the current state and our scene. And then inside of that, we update the information we care about via the board, which is what actually handles all the information about the dungeon. I think the problem is the way that the unit state is currently set up is that it has all of the ability spec info in here. And we built it this way because we were working to try and get the screen up and running. But if we look at where ability spec is used in Era of Embers, I think it's inside of the unit. It's stored inside of this mono behavior. Yeah, I've been feeling this way for a little while, so this isn't a huge surprise to me in some regards. That, like, when we built this, I was like, I don't know if this is right, but we're just going to put it in here. And then we did run into some serialization issues with all of this, but it always felt weird to me that we were saving all of this information across, because, like, we don't need most of this in order to save the current state. We mostly just need the skill points, your experience level, like node total we obviously don't need to be saving. Like, there's just a lot of extra data in here. This is a class that is meant to operate This class is meant to operate the skill tree. And it has some data inside of it that we would want to save. But I don't think we want to save the entirety of it because it's just too much. We're over saving information as well. Not that I expect our save files are going to be huge, but still. It's not ideal. So okay. This shouldn't live here. But if it doesn't live here, where does it live? Inside of the old system, it lived on each unit, because each unit had its own information. But we've moved most of that idea, like stats, for example, to be part of this unit state. But stats makes a lot more sense to be here. Because it's mostly just the raw array of integer values. But we still have a stats class, right? We still have a... here. Which handles a lot of the actual operations of the stats. But now if it's backend driven, it just uses It sets the value from the back end and gets the value from the back end instead of doing it internally. So the unit state is really only storing the save information of those stats. But that's much easier when the only thing it really is just an array of integers. So it's easy to move all of that into here. But the information we need to save of ability specs is actually a number of different values. And how do we access this now, right? Like when we want to get the unlock ability specs, we directly reference this. Obviously it's used inside of itself. And then, yeah, we have an ability spec class, but it's mostly just here to pass the information. I think this needs 2 chunks of information. I think it needs the unit state, which is like the raw information about like stats, ability specs, all that information, like the actual like data that we need to be saving. This is the thing we want to be saving. And then I think when it comes to, hey, we want to do a save, instead of just dumping the current existing class of ability specs out, we should go fetch it in the same way that the room manager does. So the room manager doesn't have any information about the visible tiles. That's all handled inside of the board. We pass in a dictionary of the information we want to compile, but the actual revealed tile information is all inside of the board. And if we didn't do this snapshot call, we wouldn't be able to get any of the information. So I think I've conflated hitting the mic, which hopefully will be cut out at this point for the YouTube video, is like a sign that maybe we should call it early for dinner. I'm definitely feeling a bit burnt out. I've been going pretty hard for the last couple of weeks. We do have holidays coming up next week, but I've still got today, and then I'm planning on streaming again tomorrow and Tuesday. We'll be back at 7, so in 2 hours and 10 minutes or so. I'm gonna think some more on this, but I think the long and short of it is we should be snapshotting. Inside of the unit state, we shouldn't store the entire concept of ability specs and all of the logic about the nodes. We should only store the information that actually needs to be saved. So we should make like an ability spec state class, which is what we actually save. And then inside of the dungeon player, no. Inside of the backend unit manager, this should have to do some sort of snapshot call similar to the room manager, where it goes out and finds the appropriate ability spec and gets the information it actually needs to be saving. And then when we load, we should actually load up the ability spec data and recreate all of the ability specs and all of the nodes that we need with the saved information. Or even, maybe not even recreate them. Maybe it's on a different system to create all of the ability specs and nodes, and the load should just populate it with the appropriate data. Interesting. Yeah, I'm gonna have to think on this for a while. But it is kind of blocking. In order for us to do a lot of the other polish, I mean, there are small things we can do around like adding the surprise icons to cutscenes and figuring out a way to hide certain tiles until a cutscene reveals them. Yeah, there's other stuff we could be doing. It just feels like the next big chapter of work is the balance pass. And now that I've got the formula working, we should be able to start getting loops in of actually going in, fighting the enemy, coming back, gain some stats, going back out and feeling the effects of those bonuses that we've unlocked. And I think once we get to that point and we start playing the loops, that's going to yield to a lot more polish we're going to want. Yeah, okay. I'm going to give this some thought. I'm going to go get some food cooked. I'm going to eat. That'll probably help my brain too. But I think, long story short, we need to figure out a new home for ability specs, and the unit state should save the ability spec data or something, and not the actual whole class itself. And then that'll allow us to not have to save the nodes. We'll still need to have also the node data saved, but it shouldn't need to know the up, down, left, right. This should be generated on load of the game. It shouldn't need to be saved in... Yeah. Anyways, I'll figure it out. We'll come back. We'll probably do that first thing at the start of next stream. Maybe I'll pencil some of it in off camera a little bit too, depending on how... No, I should take a break. I should take a real break. Okay, so where are we here? We're probably going to get to this stuff later. We've mostly just worked on the balance pass today, or for this stream, and then we'll come back after, and we're going to work at fixing ability spec saving. Well, which is super internal. I guess this is more for you, the viewer, to see. So it's fixing skill saving is probably a better way to say it. That makes it more clear. Okay. Dinner time. I'll be back in 2 hours. For now, though, this is going to be Tolhi signing out.